the bell icon to never miss a video from theory to practical.
Hello everyone, welcome to today's video lecture. So this is our lecture number 2 of our second module of engineering mechanics course. And what this lecture is about, resolution of forces. Resolution of forces. So this is lecture number 2 of our module second. So first of all friends, let me discuss you or let me give you a brief introduction of what we have done so far in our course engineering mechanics. So in module first, which was introduction of engineering mechanics, what we had discussed, we discussed introduction of engineering mechanics. Okay, in that we discussed what actually engineering mechanics is about and what are the different application of engineering mechanics in our day-to-day life and other scientific terms. That all we had discussed in our first module. Apart from that, what we discussed in our module number 1 was equilibrium equations. Equilibrium equations. What are different equilibrium equations? What a body has to do to be in stable equation, to be in stable condition. What are the equation? How do we derive equations of equilibrium for different bodies? Okay, that all we have discussed in our lecture number first. Oh, sorry, module number first. And what are the next? What was the next topic that we have discussed? Is Newton's laws of motion. Newton's laws of motion. So Newton's laws of motion, three laws of motion also we discussed in our module number first. And one more thing and very important thing that we discussed in module number first was free body diagram. Very important topic, free body diagram. We saw different examples. In fact, we have done so many examples to make it clear for you to how to draw a free body diagram of a body. Given a body, you need to find out what are the different forces acting on the body, and accordingly we have to draw the free body diagram. That all we have discussed in our module number 1. So today we are going to see our lecture number 2 of module 2nd. What we have discussed in our lecture number 1 of module 2nd, actually module 2nd is about forces, force system. So in our lecture number 1 of module 2nd, we discussed what are different forces, what are the types of forces. We discussed collinear forces, we discussed coplanar forces, we saw how to differentiate between all these types of forces. That all we have discussed in our lecture number 1 of module 2nd. Today, very important topic we are going to discuss is resolution of forces. So friends, lecture number 2, resolution of forces. Resolution of forces. Very important topic. Very important topic, I must say, from your examination point of view. And also, you will realize the importance of this topic when you will study strength of material, RCC, steel structures, and other mechanical subjects or civil engineering subjects. We are definitely going to talk about civil engineering aspect. So strength of material, fluid mechanics, and RCC steel, there you are going to see the application of this topic, resolution of forces. Very important topic from examination point of view also. Okay, and also I would like to discuss one more thing with you guys, and what that is, for those who are new to this channel and who are viewing or seeing this video for the very first time. Friends, let me tell you, we here at the Theory to Practical, we are providing you the free we are providing you the course content for RRB JEE and SSC JEE, and in fact other upcoming engineering exams preparation. We are providing you RRB JEE and SSC JEE course content exclusively. And one more thing that I would like to emphasize upon is we are providing these courses in both English and Hindi languages. Let me give you, let me tell you about this. Actually, we have been getting so many queries, so many doubts regarding this from our South Indian students that sir, please make these videos in English also. So to resolve that query, we have started, or we are planning to make other videos also in English. So we have started our RRB JEE and SSC JEE and other engineering courses in English language also. So for those who have not subscribed this channel, please subscribe this channel, and also if you want the course, you can comment out below the inbox, okay, and you can also contact on the numbers given below this video. So friends, these are all things that we had to discuss. Now we will move on to our topic, that is resolution of forces. So friends, resolution of forces. Resolution of forces. So what do we mean when I say resolution of a force? Suppose this is a force acting at some angle from horizontal direction at an angle theta. This is force F. So what do we mean when I say we have to resolve this force into its component? We mean that we want to resolve this force into its components. Okay, what are the components mean? Component mean that we are going to see the effect of this force in different directions. So for that, let me give you a simple example. You will better understand by this example. Let us suppose this is a car, a small trolley car, a toy car. I'm sure you might have also played with these toy cars in your childhood. So suppose this is a toy car and you have attached a string or a rope to this toy car, and you want to move this toy car in this direction. You have attached this string to this toy car and you are applying a force, suppose any force F. I am not specifying any quantity or any magnitude of this force. I am saying you are applying a force. What you are doing? You are pulling this car not in horizontal direction, at some angle. The string is at some angle, so you are applying the force to this toy car at some angle, but the movement of car is in horizontal direction. So indirectly, if I see that if there is no force in this horizontal direction, how can a car or a toy car can move in this direction? That we have to understand here. Because why this car is moving in this direction even if there is no force that we can directly see? Because the effect of this force is in this direction also. That is called component of this force. So to see the effect of this force in this direction, we will resolve this force in horizontal direction and in vertical direction. This is just for example. You can resolve this force in any direction, but for the sake of scientific reason, I want to see the equilibrium of this body in horizontal and vertical direction. I hope you got the point. So even if there was no actual force acting in this direction, in horizontal direction, there was movement of this trolley car. And how did that movement come from? This movement came from the component of this force in this direction. Suppose this force in the string was acting at an angle of theta from this horizontal direction. So if I have to resolve the force in this component, what do I want to say? We are going to see the effect of this force in both horizontal and vertical direction. Component of a force means effect of that force in different direction. That is actually what I want to emphasize upon. Component of a force means the effect of that force in a particular direction. So even if the force was acting at some angle, there is movement of this car in horizontal direction due to what? Due to the horizontal component of this force. And when we talk about the equilibrium, we want to see for a student, there is no purpose to see the equilibrium of this equation, but for a scientist, he wants to see what is actually happening, why this trolley car is happening. He would definitely apply some equilibrium equation. He would like to see the stability of this body, and for that, what he needs to do, he needs to establish some equilibrium equations. Equilibrium study. And friends, in module number 1 we have discussed, when we talk about equilibrium and when we develop equilibrium equation, we are definitely going to specify the direction of movement and in which direction we are going to establish the equilibrium. Suppose generally, for the general reference, we take horizontal and vertical direction as our reference axes. What are our reference axes? Horizontal and vertical direction. Suppose this is our x direction and this is our y direction. So I want to resolve the force. The force is actually acting at some angle. I want to see the effect of this force in both horizontal and vertical direction. For that I need to resolve the components of this force in horizontal and vertical direction. That's where you want to that's where you need to study how to resolve a force into its different components. So far we have discussed why do we need to resolve a force into its different component. So I hope now you understood why do actually we resolve the force into its different components. So this was basically introduction of why do we need to do this. Now we will discuss how do we do it. Now when you have known that why do we do it, now you should know how we are going to do it, how we are going to resolve a force, or we are going to see the effect of a force in different direction, which are called components of that force. I hope you understood so far what I have told you. So okay, now we will move on to our next thing, that is how to resolve. How to resolve. See friends, you can resolve force in two ways. You can resolve, suppose this is the force acting at some angle theta from horizontal direction and vertical direction. So these are our reference axes. Suppose this is x and this is y. This is our force F. We have to resolve, or we have to see the effect of this force in x and y direction. Now let me tell you one thing. How do you see these reference axes? These x and y directions are definitely perpendicular to each other. So when you resolve a force into its different components or two components which are in such a way that they are perpendicular to each other, they are called rectangular components. So I can say, when I resolve this force in x direction, which is called fx, suppose I say I write it as fx, and I resolved force F into y direction and I called it as Fy. So Fx and Fy are what? Are the component of force in x and y direction. And as you can see, both these components are perpendicular to each other, means they are making a 90-degree angle between them. You can clearly see here at the origin fx and fy are perpendicular to each other. Such components which are perpendicular to each other are called rectangular components. These are called rectangular components. I hope you are getting what I am trying to say. These are called rectangular components. Are there another way? Is there another way to resolve the components of a force? Yes. It is not necessary that always these forces will be perpendicular to each other. They can make any other angle, 30, 60, which is not 90-degree, and in that case those components are called angular components. They are called angular components. Rectangular, when the components are making 90-degree angle between them, they are called rectangular components, and other are called angular components. Okay, so now when we have got to know how to resolve what are the types of components, those are rectangular and angular components. Now we will actually see how do we do it, how do we resolve the components. First of all, we are going to see how to resolve a components in perpendicular direction. That means we are going to talk about rectangular components. How do we resolve a component of a force in two perpendicular direction? Okay, this is our next topic. Okay, now we will see how to find rectangular components of a force. rectangular components of a force. Okay, suppose this is a point, and at this point, suppose this is a particle, and at this particle a force is applied. A force F is applied in this direction, and the direction of this force is at an angle theta from horizontal direction. So definitely, suppose this is our x direction, and perpendicular to this is y direction. This is our origin O, where the force is acting. This is y direction and this is our x direction. So x and y, these are our reference axes. Now I want to resolve this force into two components, into two rectangular components. So rectangular components will be along, one will be along x direction and the other will be along y direction. So this is suppose fx, and in y direction this is suppose y fy. So I want to find out what will be the magnitude of fx and fy, which are component of this force or the effect of this force in x and y direction. Okay, let me name it first O A. Suppose this point is B and this is C. Now for a while I want all of you to concentrate on this triangle OAB, triangle OAB. Pay your attention to this particular triangle. We are going to apply some trigonometrical properties, and accordingly we are going to find the component or the magnitude of this component along x and y direction of force F. Now in triangle OAB, what will be cos theta? Tell me, what will be cos theta? You already know what is sin theta? Perpendicular upon hypotenuse. And what is cos theta? Base upon hypotenuse. ठीक है? So cos theta in triangle OAB, cos theta. What is cos theta? Base upon hypotenuse. What is base? OA, and hypotenuse OB. Now as we know, OA is what? Fx. OA is what? Fx, and OB is F. This is our force F, main force F, of which we need to find components. This is what? F. So OB is what? F. So from this, Fx will be equals to F cos theta. This is the resolution of force F in x direction, the magnitude of which is F cos theta. So suppose this force was 30 kilonewton and this angle was theta is 60 degree. So the effect of this 30 kilonewton force, which is acting at an angle of theta which is 60 degree from x axis in the direction of x, will be Fx is equals to F cos theta, means 30 into cos 60. So 30 into cos 60, cos 60 means sin 30, that is half, and it is 15 kilonewton. So which means in actual condition at this particle O, a force of magnitude 30 kilonewton was acting. I want to see the effect of this force in x direction. So I saw that the out of this 30 kilonewton, this 50 kilonewton force was acting in x direction and the rest will act in other direction, perpendicular direction. That's why these components are called rectangular components. So I want to indicate the same example that I have given you in the last lecture, which was, this was our toy trolley, and a force, let us suppose a boy was pulling it with a string by applying a force of 30 kilonewton. So as I already told you, there was no actual force in x direction. In horizontal direction there was no actual force, but still that there is movement of this trolley in x direction because of the component of this force which is of 30 kilonewton in x direction. And now Now at this stage we are able to find out what is the magnitude of this particular component. So we can say 30 cos 60. By applying the same example, we are saying that 50 kilonewton force. So actually in horizontal direction 50 kilonewton force is acting, which is pulling the toy trolley. Are you getting my point? Why do we need to resolve the components of a force? And when we know how to and when we know we need to resolve the components, how do we do it? That also we have now got it from this point. Okay, so a 50 kilonewton force will be acting in horizontal direction, due to which the trolley will be moving, and the other force component which will be in vertical direction, that is Fy. What will be the magnitude of this vertical component? That also we need to find. Okay, now I want all of you to concentrate on this triangle OCB. Pay your attention to this triangle OCB. Triangle OCB. Now triangle OCB. So if I am taking triangle OCB, then I need to define this angle. OCB, I need to define this angle. So this will be 90 minus theta, because this total angle is 90, this one is theta, so this will be 90 minus theta. So the taking a component of 90 minus theta angle would be kind of a tedious process for you at this initial stage. So I would again ask you to concentrate on this triangle only, in triangle OAB only, OAB. So we are going to define it in another way. We are going to define the y component, that is vertical component of this force, in another way. For that I am again asking you to concentrate or to pay attention in this triangle OAB and write the sine theta component. What is sine theta? I have already defined sine theta is perpendicular upon hypotenuse. What is perpendicular? In OAB, what is perpendicular? AB. And again hypotenuse OB. Now AB, since OABC is a rectangle, one more thing here, it is OABC is rectangle. This is one another reason why we call these component Fx and Fy as rectangular components. Are you getting my point? We are resolving two components of a force perpendicular to each other, and when I complete the polygon, I find it is a OABC is a rectangle. Now since these two components are making rectangular, that's why we call it as rectangular components. So this was one other interesting observation that I told you. So now come back to the point. Sine theta is AB upon OB. Now since OABC is a rectangle, definitely the AB has to be equal to OC. AB will be equal to OC. So instead of AB, I will write OC upon OB. Now sine theta will be equals to, what is OC? OC is Fy, that is vertical component of force F. Fy. And what is OB? OB is our main force, that is F, force F. So from this, Fy is equals to F sine theta. So apply this example to the example I have already told you, that toy trolley. So in that case 30, this was suppose 60 degree. So in that case, when 30 kilonewton force was acting along the string, when the boy was pulling the string with a force of 30 kilonewton, we saw the horizontal movement of the car due to the force of 15 kilonewton, which was horizontal component of this force. Another component in vertical direction, which is F sine 30, yani F. What is F? 30 into sine is what? 60. So 30 into sine 60 is what? Cos 30, that is root 3 by 2. So this is 15 root 3 kilonewton. Are you getting my point, friends? Are you getting my point? So we have resolved this force of 30 kilonewton into perpendicular direction, which are called rectangular components. Sorry, now I would like to tell you a trick here. Whenever you have to resolve a force into its rectangular component, what you will do? this is a small derivation just to make you understand how do we resolve the components, rectangular components. But but when you will be solving some actual problems in exam, you will not have so much time to calculate all these things. So what you're gonna do, if you see a force like this at some angle theta, any angle theta, and you have been asked to resolve the component of this force in two perpendicular direction, that is rectangular components, what you're gonna do, you will place the uh, the axis which is making angle theta with the force. You are going to take the cos component of this force in this direction, and perpendicular to this you will take sine component. Are you getting my point? So where you have to take, in which direction you have to take cos component when you are calculating it very fast using in some numerical, you are going to take the cos component of the force with that axis which is making angle theta with the force, and the other component will be sine theta component, that is f sine theta. So cos component of the force in the direction which is making angle theta with the force, and in other direction it will be sine component of the force. This is the fast way to resolve the components, that is rectangular components. Now what we are going to do, we are going to take some simple examples to make you feel comfortable about this concept, or to make you understand this concept clearly. Okay, let's move ahead.